Uh, Good morning.
Good morning. How are you?
I'm good. How are you doing, Cheryl?
I'm a little bit tired, but I'm okay.
Yeah.
Been getting a lot of work done.
Oh, good. Good. I saw that you are all the way up to Unit 7 practice test, so you're super on track and you did a good job.
Yes. Thank you.
Ayla, what about you? How are you doing?
I'm okay.
Yeah. You look like you're on track as well. I think
Yeah,
you
I don't
I think
ever like to
you
turn anything.
sorry, say that again. I didn't mean to interrupt you.
No, I'm someone who doesn't turn in anything late. I hate doing that. So
Gotcha. Well, you're doing a good job, and I think you what have still have the practice test to take and then the unit test, right?
yeah,
Okay, that's what I thought. Okay, good. Yeah, you guys are right on track. And you guys both did well, I know Cheryl, you did well on the practice test, and Ayla, I think the unit 7 quiz you did really well on as well. So do you feel like this unit, you guys, is a little easier to understand than unit 6?
Absolutely.
I agree.
I have a
I
question though,
agree.
'cause I keep
Uh-huh.
on getting the same question wrong. It's like the pressure one, like the picture, trying to show which diagram has the highest pressure, and
Uh-huh.
I think I got it wrong 3 times, like on the
On the
quiz.
practice test?
Yeah, it's on the practice test and the quiz, like in that
Um,
unit. It's like the green balls like scattered and then some are close together.
yeah, gotcha. Hold on. Let me just pull it up. I just need a visual here real quick here. Mhm. Get in the right unit. You said the unit 7 quiz and the practice test both?
I don't know which quiz, but I know it's on the practice test for sure.
Okay. Let me pull that guy up. Are they the dots in the green or like in green dots in a blue box?
Yes, that's it.
And it says which diagram would have the highest pressure, assuming they are all at the same temperature?
Yeah, it's that
That's
one.
the one. Yeah, okay. Let me real quick here. Okay, let me show you what the picture is and then I'll explain it to you real quick here. Well, I'll just share my screen. This is how you would figure it out. Can you see my screen?
Yes.
Okay, so this is what they're doing. You have to count up the number of particles in each box. And the second one, because the more particles, the more collisions and the higher pressure you're going to have. So if you were to count up each box, you'll find that that second one has the most dots in it. So the first one has got 1, 2, 3, 4, 5, 6, 7, 8, 9. The second one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The last one has 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have almost, well, you've got double the amount in that second box than the first two, or the first and the second. And so the more particles, the higher pressure you're gonna have.
I thought so because I chose that on one of the quizzes and it said it was wrong. So I don't know if it was like a glitch in Bright Thinker.
Oh, goodness. Huh. Well, that's
Because
kind of
like the
weird.
less surface area means more pressure. I mean less, yeah.
Yeah. Let me see if I can find the quiz and maybe that is a
I mean, I
little
still
bit.
got a good grade. I was just wondering why I
Yeah.
got it wrong.
Well, I'll investigate. I don't, that's kind of, it is kind of weird. I mean, if that's what you, um, I'll investigate and I'll send you a chat. How's that?
Okay.
That sound
All right.
okay? Yeah, because that's B is the correct answer. Okay, so I thought I would talk just a little bit today and tomorrow, and I'll let you guys know, like, next week is a crazy week here at EIA and for teachers. So next week we don't have any classes. There's no Teams meetings. Because Tuesday I normally don't have class, but Wednesday's parent teacher conference is all day. Thursday and Friday of next week, all of us teachers are at a digital learning conference. So check with your other teachers and just make sure, you know if there are other classes that you attend on Teams. Just realize that Wednesday, Thursday, and Friday we'll have no Teams meetings. So kind of keep that in mind. What I am going to do, however, since I'm not going to have those, there's two kind of not tough, but I will kind of tough. There's two concepts that are coming up that I would have taught next week over precipitation reactions and solubility. So I'll make a video for that and then I'll upload it into Bright Thinker. And then also how to calculate molarity. So there's some new calculations. So I'll do a video for both of those and upload those into Bright Thinker to help you guys out. Okay. And on that Wednesday, Thursday's crazy because of the conference, but Wednesday with parent teacher conferences, like if you have questions, you can just message me or email me, and I'll be able to check it between conferences. I just don't know how busy I'm gonna be conference wise. That makes
Okay.
sense?
Isn't there like a in-service day where we don't have school? You said that, right?
There is an insert, hold on. So the 14th, I think, is an in-service day. Which would be, yeah, so the 14th is a district in-service day, so that's Friday. Thank you for reminding me. I don't think I said that. And then the 17th, we have the day off, which is the next Monday, because it's President's Day, I think. Yeah, it's President's Day. So you guys have that Friday the 14th, Valentine's Day off, and then Monday the 17th off as well.
Okay, because I just wanted to tell you in advance, I have a trip to go to. I think it's February 27 to March 3rd. So if I
Oh,
don't make it to
wow.
any of the meetings, I won't be
That's
able.
why.
Yeah.
Gotcha. Okay. Well, you obviously, you know where to get the recordings. So
Yes.
where are you headed to?
Milwaukee, Wisconsin. I'm going to like a conference.
Oh, how fun. You think the weather's gonna be okay?
I talked to some people that live there and they said it's still going to be cold, like more cold than it is here, because I think they have like more of a wind
Mm-hmm.
breeze. So
Oh. Well, it'd be nice to get out of here and be someplace different.
yeah, absolutely. I might bring my computer, but I don't know how things are going to turn out. So I might not
Gotcha.
feel like it.
Well, if you can work ahead and then maybe you can just, kind of relax when you're there.
Oh, yes, that's the plan.
Cool. Okay. Well, I thought I would talk a little bit about properties of water today. Just sort of an introduction to Unit 8 because it's all about water and solutions and solubility. So we're kind of switching directions just a little bit. No calculations until I think it's lesson 4 or 5. So you get a little bit of a reprieve there. So I'm going to talk a little bit about the beginning of Unit 8, unless you guys have questions about anything else.
I don't have any questions.
Ayla, what about you? Do you have any questions about any problems or anything?
No.
Okay, then I'm gonna start talking. Let me share my screen. My office is sometimes really warm and sometimes really cold, and today it is really warm. Okay, so unit, I have unit 7. It's actually unit 8. Um, Unit 8 is all about water, properties of water, and certain things dissolving in water. So I just wanted to talk a little bit about the properties that make water very unique. So first of all, I'm sure you've heard it before. Have you heard people call, or maybe your previous science teachers call water the universal solvent?
I think so.
Yeah. So you hear it quite often, and that's just because water will dissolve more substances than any other liquid. And so it's considered the universal solvent. And water is really important in chemistry because a lot of chemical reactions happen in water. So anytime you're doing a chemical equation or you're looking at an equation, if you guys remember, like if you are doing like a chemical equation, you've got your state of matter. So like remember G is gas and H2O, L is liquid. You guys remember that from the last chapter or whatever, the last quarter. So these give you the states of matter of the substances. So gas, gas, liquid. So anytime you see AQ, that means that the substance is aqueous. It means it's dissolved in water. So later in the chapter, we'll go back to chemical equations. We'll look at double displacement equations. So like Ki, which is aqueous, which means it's dissolved in water, plus lead 2 nitrate. Oh, that's a funky 3. Yields, and this will be aqueous. So you'll see this pop up in unit or in lesson 4, and that just means these substances are in a solution or they're dissolved in water. So solution, that's when you have one substance dissolved in another. So if you take sugar and you put it in your coffee and it dissolves, that's a solution. If you put salt in water and it dissolves, that's a solution. So a solution is going to have your 2 parts. You'll have your solvent, which is in abundance, and then you'll have your solute, which is actually being dissolved. So solute is being dissolved, solvent does the dissolving, and then the 2 of them together makes up our solution. Solutions are also called, now you have to go all the way back to, I think it was unit 2 in the first quarter. But a solution is also known as a homogeneous mixture. So it looks the same throughout. You cannot see the component particles that make it up because one is dissolved in another. Now, the properties of water, you guys, come from its very specific type of bonding. Now, I'm going to have to go back to, I think it was unit 3, maybe, 3 or 4 when it talked about bonding. So if you remember, when electrons are shared, if they are shared equally, they form a nonpolar covalent bond. If the electrons are shared unequally, okay, they form a polar covalent bond. And if you have polar covalent bonds, you have a polar molecule. So water, as you guys can see here, and I took this graphic off of Bright Thinker. Here's our water molecule, the 2 H's and the O's. So what happens is the O is bigger in this model or in this diagram because the electrons spend more time, like my shared electrons here, spend more time around oxygen. So it makes oxygen just a little bit negative and it makes hydrogen just a little bit positive. So you have a little negative here and you have a little positive here. That's what makes a polar molecule. And that polarity really gives water a lot of its properties. Okay, so if you have water molecules bonded together, oxygen is negative, hydrogen is positive, so these opposites attract. And this bond is a hydrogen bond that holds these two molecules together. So hydrogen bonding is an intermolecular force that is found between different molecules. And again, that hydrogen bonding is actually pretty strong. It's a pretty strong bond. So between the hydrogen bonding and the polarity, that's what's going to really contribute to water's different properties. So adhesion is when water molecules are attracted to other substances. So like if you've ever, put water in a glass, drank it, and put it down, you still see water on the inside of the glass. That means that the water molecules are stuck or are attracted to that glass. So that's adhesion. Cohesion is basically hydrogen bonding. So when water molecules are attracted to one another. And again, the polarity or the structure of the water molecule contributes to these properties. So cohesion is basically hydrogen bonding. Adhesion is when water sticks to other substances. Surface tension. So surface tension is basically a force that is produced by that hydrogen bonding that will allow different things or substances to actually kind of float on the water. So that bonding, the hydrogen bonding, is a force, and a force is a push or a pull. So it's like a force that's pushing upwards. So these little kind of skater insects will walk on water because the water molecules, that hydrogen bond is really strong, and these guys cannot break that bond. You can also make like a paper clip. I've done a lab in the past that has you like make a paper clip float on a beaker of water, just like it is here. And the thing that causes it to float, because really a paper clip is more dense than water. So it would technically like sink if you're just to plop it in there. But if you gently lay it on there, that force, that surface tension is allowing that paper clip to actually make it float on water when it's really actually more dense. And then what you do is if you could put like a drop of soap on it, and that soap will break those hydrogen bonds and then cause that paper clip to actually drop. So technically that should sink, but that hydrogen bonding of that paper clip or of the water makes that paper clip float, just like our insect right here does. So those are the first three properties that make water unique: adhesion, cohesion, surface tension. Our next one is called capillary action. So adhesion to the walls of a container is stronger than the cohesive forces between the molecules. So this is used, or you see capillary action when water is absorbed by the roots of plants, trees, and then it goes upwards, which is kind of strange because you've got gravity pushing downwards, but that capillary action actually causes the water to actually move upward in order to get to the stem and to the leaves. So that attraction to the inside of the stem or the leaves is going to cause the water to actually kind of move upward, which is kind of strange because normally with gravity, it would move downwards. And then this, if you're familiar with the labs, anytime you measure water in a graduated cylinder, so that rounded curved surface, do you guys remember what that's called?
A precipitate?
Oh, good guess. Not quite. Ayla, do you remember what that curved surface is?
No.
No, that's fine. That's called the meniscus. You're probably going to be like, oh, yeah, now I remember. So that curved surface is called the meniscus. So anytime you put water or another substance, okay, in a graduated cylinder, you're going to have this capillary action and you're going to have the liquid, okay, that is more attracted to the water. And so it's going to cause that curve like the water is trying to travel up that graduated cylinder. And it makes this curved surface, which is the meniscus. So anytime you measure a liquid in a graduated cylinder, you always read at the bottom of the meniscus to get your correct volume. But that's a great example of capillary action. That liquid, in this case water, is being more attracted to the sides of the graduated cylinder. So that's why we get that curve. So we have adhesion, cohesion, surface tension, capillary action. The next one might be brand new to you guys. It's called specific heat. So the specific heat capacity of a substance basically is how much heat energy can a substance absorb before the temperature goes up. So here, water has a very high specific heat. So if you're to look at this chart, and this is just a small chart of different substances, but water has got a very high specific heat. It's 4.184 joules per grams times degree Celsius. So that means, okay, if we have 1 gram of water, it will absorb 4.184 joules of energy before the temperature goes up by 1 degree. And that is really important. That makes water, absorb a whole bunch of heat before the temperature goes up. And I always like this example. Okay, so think back in the summer when you guys are at the swimming pool. And if there's concrete around the swimming pool, the concrete is really hot and you have to actually like wear flip-flops on that concrete because it is really hot. But then you get your feet in the water or you jump in the water and the water's nice and cool. And that's because of water's high specific heat. Concrete, they're sitting outside for the exact same amount of time, but that concrete gets really, really warm because it has a low specific heat. So concrete has like a specific heat of, I think it's like 0.84 joules per grams times degrees Celsius. So for concrete can absorb 0.84 joules of energy for every gram, okay? And then the temperature will go up 1 degree. So every 0.84 joules of energy that is absorbed by the concrete causes the temperature to go up by 1 degree. So that means the concrete cannot absorb that much energy before the temperature rises. But water can absorb that energy and absorb a lot of the energy before the temperature goes up. That's really important, like in the environment and aquatics, because it allows water not to freeze very, very, very quickly. And it also freezes from the top down. So a lot of like aquatic life can actually still live on the bottom of like a lake or a pond. And that is due to water's high specific heat. And if you look at the chart, can you guys notice how a lot of these metals have a very low specific heat? So like aluminum, chromium. Do you guys remember from in the past how we say that metals are good conductors of heat and electricity, right?
Yeah.
Okay, so that's why. So all these metals have a low specific heat. So that means they absorb very little energy and then the temperature goes up, which is good because we want metals to have heat flowing through them very, very quickly, because they're considered good conductors. But water would be more like an insulator. It's going to pack in a whole bunch of heat energy before the temperature actually goes up. So that's one very, very unique property of water. And I think we're like made of like 60% water, if you were wondering. Okay, I got one more unique thing about water, and then I've got a really good video on it. I don't know if you guys remember, I don't drink water with ice in it that often because I'm always cold. But if you plop an ice cube into a glass of water, that ice is actually going to float, which is weird because most substances in their solid form will actually sink in their liquid form because the atoms are so packed together in a very tight space, making the solid of that substance more dense than the liquid. So normally, it would, if I was talking about mercury, okay, if mercury was in solid form versus liquid form, the solid form would sink in the liquid. Water is different. So water in the solid form, which is ice, is actually going to float, okay, in water, the liquid form. And that's because, can you see these hydrogen bonds? See how they're all spread out? The spreading out of those hydrogen bonds actually makes the solid form of water less dense. So it's like right here, 0.91 grams per milliliter, and liquid water is 1.00 grams per milliliter. So water in the solid form is actually less dense than the liquid form, so ice is going to float on water. And that has everything to do with the polarity and that hydrogen bonding. It literally just spreads out and make it a lot less dense. So Unit 8 is all about water. It's all about solutions and different solutes and different types of solutions. So water's like the main player. I'm going to show you do you have any questions so far? I think it's pretty straightforward. You just kind of have to go back to that chemical bonding all the way back to that first quarter.
Right. I don't have any
Yeah.
questions.
Okay, Ayla?
No questions.
Okay, I am going to show you a short video, this is a TED Ed video, which I really like. So I'm going to stop sharing here. And then I'm going to share here. My goodness, my technical skills are getting so much better. Hold on. Maybe not. Let me try it again. There we go. Make sure you can hear it. Okay.
Attention Puget Sound Energy customers. PSE rebates are at an all-time high. Call today for a free inspection to see if
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared, but As we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atoms in neighboring water molecules. A special type of bond forms between water molecules, known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension, due to hydrogen bonding, creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state. But that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
Okay, ladies. That is it for today. Sherelle, I looked at your practice quiz, and you know what they did to you? They switched. So when I pulled it up, I guess they switched the numbers around. So the box with the most dots in it was on the bottom. So they switched those two boxes,
Okay.
just so you know, and that, yeah, so I don't know. So maybe in the example, they had it switch or something like that, but that's what I'm seeing right now. I just clicked into your quiz and it looks like the one with the higher pressure was on the bottom and then the two lower pressures were on the top. So they just swapped it.
Thank you.
Okay. Okay, any questions?
No. Thank you for your
Okay.
time.
Oh gosh, thank you guys. Tomorrow I'm gonna look at solubility charts because I think that's something that you probably haven't come into like contact with. I don't think you've probably ever dealt with them. So we'll do a bunch of practice problems and talk about how to read those solubility charts. So when you get to those assignments, you guys will be in the know. Sound good?
Yes.
Okay, you guys have a great day. Thanks for coming.
You too. Bye.
Bye-bye.